Good morning, students. Welcome to online class, Department of Collegiate and Technical Education, Automobile Engineering Department, 5th semester. Name of the subject is Design of Machine Elements. So, we are in unit number 4, that is Design of Simple Machine Parts. So, today we are studying session number 10, that is solved examples on quarter joint. Before studying this session, let me introduce myself. I am Mr. Vinayak S. Nayak, Selection Grade Lecturer, TSIT Polytechnic, Hubli. So in previous session, that is session number 9, we have studied regarding the design procedure of quarter joint. So in that we have designed the diameter of the solid rod or bar and designing of socket, designing of spigot and designing of quarter. So by referring the design data handbook, so we have designed around 12 steps or 12 dimensions of the quarter joint. So today in session number 10, the content of today's session are: number 1, some short examples on design of quarter joint. In this, we will solve some simple examples on design of quarter joint. Number 2, question answers and homework. Here we have some unsolved problems as a homework and some multiple choice questions. Again, we have to choose the correct answer in the multiple choice questions. Third one is multiple choice questions. So here already we have familiar and we have to select or choose the correct answers. And fourth one is the references. So in this, the books which I have referred for preparing this session, as well as the data handbook which I have referred for solving the problems. Dear students, we'll study one by one. Number 1, some short examples on design of quarter joint. So problem number 1, design a quarter joint to connect two MS rods for a pull of 30 kilonewton. The maximum permissible stresses are 55 megapascal in tension, 40 megapascal in shear and 70 megapascal in crushing. Dear students, before solving the problems, we must read the problem carefully. Then we have to understand what are the given data and what is the question or what we have to design. Here we have to design a quarter joint. So to design a quarter joint, already we have familiar, there are 12 steps to design a quarter joint that we have studied in the last class. And after reading the problem carefully, we have to write the given data. So what are the given data, and if there any conversion, we have to convert into standard units. So here the given data, the pull of 30 kilonewton, that is capital P is given 30 kilonewton, but our unit is in the Newton, so we have to convert into kilo into Newton. So already we know that 1 kilonewton is equal to 1 into 10 raised to 3 Newton. So P is equal to here 30 into 10 raised to 3 Newton. Then tensile stress, 55 megapascal. So already we have know that 1 megapascal is equal to 1 Newton per mm square. So sigma T is equal to 55 Newton per mm square. Shear stress tau is equal to 40 Newton per mm square, and crushing stress sigma C is equal to 70 Newton per mm square. After writing the given data, we have to design the quarter joint as follows. So again we have 12 steps, and by referring the design data handbook written by K. Mahadevan and K. Balavir Reddy. So we are referring that design data handbook. So you just open page number 65. So in that we have some equations that we have studied in the previous class. So first one, diameter of rod. So with respect to the tearing resistance of the solid rod, and using the equation 4.16a, page number 65, which is in the data book, that is P is equal to pi by 4 d square into sigma T. So by substituting the values of P, sigma T, so the value of D, that is the diameter of the rod, is 26.25 mm. So it is around 28 mm. So that is the diameter of the solid rod. Similarly, second one is the diameter of spigot and thickness of quarter, that is D1 and T. So to calculate this, we are referring the data book page number 65, and the equation is 4.16c. Again, by substituting the values of P and sigma T, and also thickness, that is T is equal to 0.25 D1. So the value of D1 is equal to 32 mm, and the thickness of quarter T is equal to 0.25 D1. So that comes to small t is equal to 8 mm. So here just we are substituting the values, and by simple calculation we can calculate D1 and T values. After calculating this, we have to check for induced crushing stress. So with respect to crushing resistance of quarter and rod end, by using the equation 4.16b, which is on page number 65, that is the equation is P is equal to D1 T into sigma C. So by putting the values of capital P, D1 and T, the value of sigma C becomes 117.18 Newton per mm square. But the given value of sigma C is only 70 Newton per mm square. Hence, the dimensions of D1 and T, which we have calculated are not safe. Therefore, we have to calculate the new values of D1 and T by taking the value of sigma C is equal to 70 Newton per mm square. After substituting the value of sigma C is equal to 70 Newton per mm square, the value of D1 comes 42 mm, and thickness of the quarter is 10.5 mm. So we have to consider these values because these values of D1 and T are safe. So next we have to calculate the diameter of spigot collar D2 by using the equation 4.16D, and by substituting the values and doing the simple calculation, the value of D2 is 49 mm. Similarly, fourth one, the value of T1 is 6 mm by using the equation 4.16E. Next, fifth one is the distance from the end of slot to end of rod, that is L1. So by using the equation 4.16G and doing the simple calculations, L1 comes 9 mm. And here the sixth step, that is outside diameter of socket, that is capital D1. So here by using the equation 4.17A, which is on page number 67, and by substituting the values of P, D1, T and sigma T, so here the equation comes 0.785 D1 square minus 10.5 capital D1 minus 944.26 minus 545.45 is equal to 0. After simplification, 0.785 D1 square minus 10.5 D1 minus 1489.71 is equal to 0. So here we have two unknown factors, that is a D1 square and D1. So hence by using the quadratic equations, so we can solve this equation. So first we have to divide the whole equation by 0.785 because the coefficient of D1 square must be 1. So to get the coefficient of D1 square 1, we have to divide the whole equation by 0.785. So the equation becomes capital D1 square minus 13.37 D1 minus 1896.99 is equal to 0. So using quadratic equation, so the quadratic equation is capital D is equal to minus B plus or minus under the square root of B square minus 4AC whole divided by 2 into A, where small a, B and C are the coefficients of the equations. Here the coefficient of A, B and C are A is equal to 1, B is equal to minus 13.37 and C is equal to minus 1896.99. After substituting the values of A, B and C in the quadratic equation, so and after calculation we are getting two values of D1, that is one is positive value and another is negative value. So the values are D1 is equal to 50.74 or minus 37.37. So we have to consider the positive value, that is 50.74. so the value of capital D1 is equal to 51 mm. So in the sixth step we have to use the quadratic equation for solving the value of capital D1. So other steps are simple calculations, but the sixth step is we have to use quadratic equation. Similarly, the seventh step, the diameter of socket collar, that is capital D1. So again we have to use the equation 4.17 and after calculating capital D is equal to 83 mm. Similarly, eighth one, thickness of socket collar, that is by using the equation 4.17c, which is on page number 67, that is value of L is equal to 10 mm. Then next is width of quarter. We have to use the equation 4.12a, and the value of small b is equal to 36 mm. So the 10th one is the length of quarter, that is 4 into d, so that is equal to 112 mm. 11th one is the taper in quarter is 1 in 24, and the clearance of quarter is 2 to 3 mm. So like this we have to solve around 12 steps or 12 dimensions to design the quarter joint. So dear students, I think you understood this problem. Similarly, we will solve another problem. Problem number 2. Two rod ends of a pump are joined by means of a quarter and spigot and socket at the ends. Design the joint for an axial load of 100 kilonewton, which alternately changes from tensile to compressive. The allowable stresses for the material used are 50 megapascal in tension, 40 megapascal in shear, and 100 megapascal in crushing. So dear students, here also by reading the problem carefully and understanding the problem, first we have to write the given data, and if you have any conversion we have to convert. Then we have to start the designing of quarter joint. So again we are familiar, we have 12 steps. So, and also by referring the design data handbook written by K. Mahadevan and K. Balveer Reddy. So again, first one, diameter of rod we have to calculate by using the equation 4.16a, so that becomes 51 mm. Similarly, number 2, diameter of spigot and thickness of quarter, that is values of d1 and t. So here the values of d1 is 62 mm and thickness of quarter small t is equal to 16 mm. After that again we have to check for the induced crushing stress. So after putting the values of P, D1 and T, the value of sigma C, that is crushing stress, comes 100.8 Newton per mm square. So here the given value of sigma C is 100 Newton per mm square, which is approximately or nearly equal to the calculated value of sigma C, that is 100.8 Newton per mm square. So here the values of D1 and T are safe and they are satisfactory. So there is no again calculating of D1 and T, because the values of D1 and T are safe for the given value of sigma C and calculated value of crushing stress. After that, the third one is diameter of spigot collar. We have to calculate. So D2 is equal to 72 mm. Fourth one, T1 is equal to 13 mm and value of L1 is equal to 21 mm. And next is outside diameter of socket, that is capital D1. So here also by using the equation 4.17a, which is on page number 67, Again, to solve this, we have to use the quadratic equation again. So here the coefficient are A is equal to 1, B is equal to minus 20.37 and C is equal to minus 5127.97. So after calculating, again we are getting two values of D1 and taking positive value, the value of D1 is equal to 83 mm. Next is the diameter of socket collar, that is capital D, that is equal to 125 mm, and thickness of socket collar small l is equal to 20 mm. Width of quarter by using the equation 4.18a, which is on page number 67. Again the value of B is equal to 79 mm. So the length of quarter 4D, that is equal to 204 mm. Taper in quarter is 1 in 24. Clearance of quarter is 2 to 3 mm. So again we have to complete this problem by calculating around 12 steps or 12 dimensions of the quarter joint. Dear students, we have some unsolved problems. So the third one is question answers and homework. So in this we have to practice the given unsolved problems and practice the multiple choice questions. So in the unsolved problems on design of quarter joint, problem number 1 is design a quarter joint to support a load varying from 30 kilonewton in compression to 30 kilonewton in tension. The material used is carbon steel, for which the following allowable stresses may be used. The load is applied statically. Tensile stress is equal to compressive stress, that is equal to 50 megapascal. Shear stress is equal to 35 megapascal and crushing stress is equal to 90 megapascal. So dear students, you read the problem carefully and understand and write the given data and calculate one by one. So again we have to calculate around 12 dimensions or 12 steps. So for hint I am giving this. So the diameter of the rod or bar is equal to 28 mm. So if you calculate the value of small d correctly, then only you will get other values correctly. So you must careful while designing the diameter of rod or bar. So here small d is equal to 28 mm and rest of the 11 parts you only calculate. Problem number 2. Two mild steel rods 40 mm diameter are to be connected by a quarter joint. The thickness of the quarter is 12 mm. Calculate the dimensions of the joint if the maximum permissible stresses are 46 megapascal in tension, 35 megapascal in shear and 70 megapascal in crushing. So here the thickness of the quarter is given and we have to calculate the dimensions of the joint, and here I will give the hint, that is the value of P, that is load on the bar, is 57,805.3 Newton or 57805.3 Newton. So again rest of the dimensions are to be calculated before the next class. Problem number 3. Design of a quarter joint to connect a piston rod to the crosshead. The maximum steam pressure on the piston rod is 35 kilonewton. Assuming that all the parts are made of the same material having the following permissible stresses. That is, sigma T is equal to 50 megapascal, tau is equal to 60 megapascal, and sigma C is equal to 90 megapascal. So here again the hint is the diameter of the rod is 44 mm. Again, if your answer is correct for 44 mm as a diameter of the rod, then the other dimensions can be easily calculated. So the next is multiple choice questions. So dear students, again we have familiar. So the each question carries 4 answers. So one will be the correct answer, and that we must identify or we have to choose. Question number 1. Newton per mm square or megapascal is the unit of. Answers: number 1 tensile stress, B is shear stress, C is crushing stress, and D is all of these. Since the stresses units, that is a tensile, shear and crushing stresses, the units are Newton per mm square or in megapascal. So here the correct answer is all of these. That is A, B and C. So the correct answer is D, that is all of these. Second one, the diameter of the rod D. In the equation, capital P is equal to pi by 4 d square into sigma T, when P is equal to 30 kilonewton and sigma T is equal to 50 megapascal. Then the value of D is A is 28 mm, B is 18 mm, C is 8 mm and D is 38 mm. After substituting the values of P and sigma T, the value of D comes 28 mm. So here the option is A, that is 28 mm. Third one, the taper in quarter should not exceed. The options are A is 5 in 25, B is 1 in 24, C is 10 in 30 and D is all of these. So we have studied that the taper in quarter should not exceed 1 in 24. So here it is in the option in the B. So B is the correct answer. Dear students, fourth one, when the diameter of rod small d is 10 mm, then the length of quarter is, options are A is 10 mm, B is 20 mm, C is 30 mm and fourth one is 40 mm. So the length of quarter is 4 into D. So when we calculate 4 into 10, it becomes 40 mm. So here the option is fourth one, that is D is the correct answer, that is 40 mm. Fifth one, the distance from the end of rod L1 in capital P is equal to 2d1 L1 into tau, when P is 100 kilonewton, small d1 is 62 mm and tau is 40 Newton per mm square. Then the value of L1 is, the options are A is 18 mm, B is 19 mm, C is 23 mm and D is 21 mm. So here again substituting the values of P and D1 and tau, the value of L1 comes 21 mm. So here the option is in the D is the correct answer. Sixth one, diameter of socket collar capital D in capital P is equal to capital D minus small d1 into T into sigma C, when P is 30 kilonewton, d1 is 38 mm, small t is 9.5 mm, sigma C is 90 mm, then the value of capital D is, the options are A is 74 mm, B is 64 mm, C is 54 mm, and D is 45 mm. So after calculating and substituting the values, the value of capital D is 74 mm. So A is the correct answer. So seventh one, thickness of the socket collar L1. Thickness of the socket collar small l in capital P is equal to 2 in bracket capital D minus small d1 into L into tau, when P is 30 kilonewton, D is 74 mm, small d1 is 38 mm, and tau is 35 Newton per mm square. Then small l is, the options are A is 8 mm, B is 10 mm, C is 12 mm, and D is 14 mm. So again, after calculating, the value of L is 12 mm. So C is the correct answer. Next, eighth one, width of the quarter B in the equation capital P is equal to 2 into B into T into tau, when P is 100 kilonewton, T is 16 mm, and tau is 40 Newton per mm square. Then the value of B is, A is 69 mm, B is 79 mm, C is 89 mm, and D is 99 mm. Again, after calculating, we are getting the value B is equal to 79 mm, which is in the second option, or B. So B is the correct answer. Dear students, so these are the references. So these books I have referred for preparing this session, as well as Design Data Handbook written by K. Mahadevan and K. Balivir Reddy. So for solving the problems, you also refer the same data handbook. Now I conclude this session. I am thankful to our LMS team, our chairman sir, LMS coordinator, moderator, subject expert, for giving this opportunity to me to present this session. If you have any queries or doubts, please mail me, and my mail ID is tsitVnaik@gmail.com. Thank you very much.